Hello folks, this is Shiltwood speaking here. Today I'm going to talk about the three attributes of fusion. Now, there's two types of fuses that have been used, that are being used, right? You have the older halogen fuses and today's sleeve type fuses, which is based on ceramic. These type of fuses have been around since the early 90s, ever since the Energy Star requirements were prepared by the US government. This gave manufacturers guidelines to have more energy efficient devices. As a result, Canon released the sleeve type fuser starting with the LaserJet 4L in 1993. These were the first printers, the first Canon based printers, which is the LX, I think, to have these type of fuses. That's the sleeve type fuses, and ever since then, bit by bit, that was a personal printer at the time. That was a new standard that was being released back in 1992 and 1993. It was designed around that time when Energy Star first came out. Around that time, they had more energy efficient devices, and it does save power too. With the old halogen units, basically took up too much power. Yeah. And now I'll get into the three attributes of fusing, which is actually common with both units, both these type of fuses. Now you have time. The time the paper stands inside the fuser to melt the toner, of course, onto the paper. Then you have heat, which is either halogen or ceramic. And also you got pressure, to put the pressure of the paper against the roller or the film. Now if any of these is out of balance, then you have print quality issues, either by totally rubbing off or by ghosting. And you can sort and yeah. So remember, these sort of problems usually happen if the printer inserts a thick piece of media into the unit and it's too thick. So that means that the paper, that the toner does rub off if there's not enough time, which is the time attribute of the fuser assembly, and the toner simply rubs off because there's not enough pressure or melting into the media. That's with thick paper. Plain paper is thinner. In theory, you can go fast. Machine can go as full fast speed up to 55 pages per minute. Currently, with printers, currently is 50 pages per minute. In the future, it can go easily up to 120 pages per minute. This has been proven by the old Xeroxes of the analog photocopiers in the 70s. So paper truly can go at high speeds quite easily. Quite easy. You can go very high speeds, 120 pages per minute. Of course, that's the old halogen fuses back in that time. film type fuses didn't exist back then. 2 pages per second of the old Xerox machine in the 70s. Very, very, very primitive now. It was analog. Now, printer manufacturers now are talking about increasing the pages per minute. Now, this decreases the time that the paper is inside the fuser. Big problem there. The faster the paper goes through the fuser, the less time it has between those rollers. This creates problems between the three attributes of fusing. The more time that the paper spends inside between the rollers, the more time it can do the cooking of the toner and the paper and the pressure. Now, if any of these three attributes are out of balance, you have problems like toner rubbing off, flaking off, number one, or ghosting images. Now, I hope this video assists you in a way troubleshooting the fuser problem and the three attributes of fusing, which is again time, how much time that the paper has between the rollers, heat, the heat source, which is either by halogen or by the ceramic, and pressure between of the paper between the heater and the heater pressure roller itself. Pressure is pushing the toner into the fibres of the paper. During the paper is compressed, the paper and toner are compressed together, pushed together by the pressure of the roller or the film. So it presses the toner into the paper fibres, and this the heat melts the toner to make a permanent image on the page. Now, fuses can be very complicated to troubleshoot. However, I hope that this video helps and assists you about fusing attributes, which is time, heat, and pressure. Those are the three attributes of fusing. Thank you for watching this video.